Hermetic seal connectors are used to resolve potential gas, moisture, and particle ingress problems in high-pressure, high-altitude, and vacuum barrier applications to prevent moisture and other contaminants from damaging sensitive electronic instruments and equipment. Hermetic seal connectors produce a condition commonly referred to as air tightness and are fabricated via a glass-to-metal or lighter-weight encapsulant-to-metal sealing process. Both technologies deliver outstanding airtight performance for high-reliability applications and may be specified in a broad range of both circular and rectangular connector packaging. Glass-to-metal seal hermetic connectors are constructed in two basic formats. In matched seal hermetics, the glass material coefficient of thermal expansion matches that of the metal body or shell material. In other words, while a strong seal is created between the two materials, it is not under dynamic compression. In compression seal hermetics, the glass coefficient of thermal expansion is less than that of the bulkhead metal surrounding it. As a result, when the metal cools after the final firing temperature has been reached, it squeezes tight against the glass, which has already returned to its solid state. Compression seals are considered ideal for circular connectors, while the matched seal technology is more appropriate for rectangular connectors with their oddly shaped form factor. Compression glass seals are generally more stable over longer periods of time, demonstrating robust integrity and structural strength. Hermeticity is a measure of air tightness. Helium leak rates are the methodology used in our industry to determine the exact degree of air tightness delivered by a particular hermetic device. The extent of any leak, or the degree to which the connector materials and sealing methodologies still allow gas to pass through the hermetic seal, is referred to as the leak rate. The leak rate is measured by the volume of a tracer gas, such as helium, which can pass through the interconnect each second with a pressure differential of 1 atmosphere. The unit of measure which is commonly used in such testing is atmospheric cubic centimeters per second of helium. Various DLA specs define a leak rate measurement in the range of 1 × 10⁻⁷ cubic centimeters of helium per second as the modern acceptable leak rate for our industry, and that any current day technology that can maintain that standard over the service life of the connector is considered to have met the hermetic seal standard. The process of building a hermetically sealed connector may be applied to virtually any connector series, given suitable shell materials and wire terminations. Glenair offers hermetic class connectors in every military standard connector series we manufacture, from legacy power and signal connectors like 26482 to higher density aerospace interconnects such as D38999 Series III and IV. Rectangular connector series available in the hermetic class, again typically match sealed, include the microminiature MIL-DTL-38999 and D-Sub-24308. We also supply many non-standard mil-spec connector derivatives, including designs with crimp-removable contacts, wire shield termination band platforms, hybrid shielded and RF contacts, bulkhead feed-throughs, connector savers, and many more. We offer both glass-to-metal and encapsulant-to-metal seal hermetics in all our signature series connectors. These are the many small form factor and specialized harsh environment connectors developed by Glenair to meet specific customer requirements not addressed in MIL-series connectors. All hermetic connectors, both glass-to-metal and encapsulant-to-metal seal, utilize standard interfacial and grommet seal component parts. For applications that require either cryogenic performance to -175 degrees Celsius or high temperature performance to 300 degrees Celsius, Glenair is able to supply Thermarex series connectors with temperature-tolerant interfacial seals and O-rings. The heart of a glass-sealed hermetic connector is a preformed disc made of refined glass. The preform is analogous to the rigid dielectric in a standard environmental connector, and like that dielectric, is fabricated in accordance with MIL Standard 1560 insert arrangements for the specified number and size of contacts. This preform is loaded with its contacts and positioned inside the metal connector shell. Carbon fixture plates are used to hold the contacts in their specified positions. The assembly is then run inside a controlled temperature furnace and subjected to a gradually increasing temperature of approximately 1,700 degrees Fahrenheit. At the sealing temperature, the glass melts and fills all voids between the contact pins and shells, forming an extremely robust mechanical-chemical bond, due to both thermal expansion properties and molecular level interactions between the glass and metal. The assembly is then gradually cooled. Next, the in-process assemblies are suspended with wiring on racks based on their size and configuration and run through a series of cleaning and descaling processes designed to remove oil, oxidation, and other impurities. Following cleaning, the work goes through a bright dip process, also known as passivation, to arrest any additional oxidation of the metal parts. In-process inspection takes place and the parts move on to the next step in the process. At this point, plating is applied to the connector contacts. Without the benefit of surface plating, contacts would not be conductive enough to reliably transmit data or power. For that reason, the contacts and the contacts alone in a hermetic assembly must be plated with a conductive material, typically gold. Glass-sealed connector contacts are typically made from Kovar or specialty nickel-iron materials like Inconel or Alloy 52. In this process, each contact is individually wired twice, once on the mating interface side and again on the wire termination side, and the assembly is immersed into the plating solution. As mentioned, most glass-sealed connectors still utilize interfacial seals, gaskets, grommets, and other standard environmental component parts to ensure the parts meet specifications and pass electrical and environmental requirements. The final step in the fabrication process is the assembly of the connector with these additional elements, as well as necessary connector hardware and red banding and marking. Glenair hermetic solutions are always subjected to 100% visual and helium leak testing, electrical testing for IR and DWV, and, depending on application type, in-house pressure testing or lab-based pressure testing. The Hermetic department in Bologna has implemented these same capabilities and processes with new equipment sets and lines for thermal processes for pre-oxidation of metal components prior to glass sealing, a process step formerly only available in Glendale, but now duplicated in our European hermetic operation. Descaling and passivation steps are completed in Bologna in a fully automated line in preparation for gold plating on hermetic contacts. The Hermetic group in Bologna is also moving forward with the in-house production of the glass multiforms integral to hermetic connector production, as well as ultimately bringing glass and ceramic marking in-house. As a result of these changes, hermetic connector production capabilities in Bologna now extend to processing any design for compressed sealing with stainless steel or Inconel material, match sealing for Kovar for rectangular connector form factors, and both high production belt furnace and vacuum static furnace production lines for lower volume custom work. The operation is fully staffed with a team of experienced personnel. The interconnect industry has searched long and hard for an alternative to glass-to-metal hermetic sealing that can still meet the 10 to the -7 helium leak rate standard, but do so with better electrical performance, including better current carrying capacity and lower contact resistance. This graph shows the significant delta in electrical performance between beryllium copper contacts and the Inconel, Kovar, and nickel iron contacts typically used in glass-to-metal seal hermetics. The interest in a lighter weight solution is also significant, particularly for air and space applications. Unfortunately, glass-to-metal seal furnace temperatures are far too extreme for lightweight aluminum shells and low-resistance copper contacts. Historically, manufacturers have attempted to use epoxy potting compounds as a replacement process for glass, but conventional epoxy sealing absolutely lacks the sealing strength and mission-critical durability that is the benchmark of all mil-spec connector standards. Code Red is the Glenair branding for our signature encapsulant-to-metal sealing hermetic technology that delivers 1 × 10 to the -7 leak rate performance at a fraction of the weight of conventional glass-to-metal seal hermetics. Code Red is an innovative encapsulant sealing and application process that far surpasses historically poor epoxy sealing results. Further, Code Red hermetic connector configurations incorporate gold-plated beryllium copper contacts, as opposed to the iron alloy contacts used in glass-to-metal seal designs, significantly improving electrical performance. The material and processing have been subjected to the same qualification tests and benchmark standards as our conventional glass-to-metal seal connectors, including 100 cycles of thermal shock and highly accelerated life testing or HALT. Code Red is currently produced exclusively in our Glendale factory, Glass-to-metal seal designs are now produced in both EU and North American factories. Thermorex hermetics, with their special cryogenic and high-temperature attributes, are also exclusive to North America. Glenair's signature hermetic solutions may be applied in a broad range of markets, from conventional aerospace to military defense, downhull, and outer space. Generally speaking, our products are specified in mission-critical, high-reliability applications, as opposed to higher-volume commercial markets such as automotive or medical. Glenair has been supplying hermetic connector solutions for well over 30 years in such application areas as satellite optical equipment, thermal batteries for missile applications, hermetics for reusable launch vehicles, pyrotechnics and igniters, accelerometers and pressure sensors, military aerospace fuel tank applications, missile fusing equipment, aircraft fan engine bulkheads, ground power applications, and high-pressure, high-temperature bulkheads for the oil and gas industry. Again, the mission-critical markets we play in are in land, sea, air, and space applications with high risk of failure, such as might be experienced in a satellite, rover, ballistic missile, or submarine application.